Good morning, Year 7 mathematicians, and welcome back. Hopefully you had a nice relaxing half term and are raring to go on some more mathematics with us. So, draw a line under your previous week's work. Today's date and measuring angles up to 180 degrees is the title. Now, once again, there is an accompanying worksheet that comes with this. If you can print it off, fantastic. If you can't, not to worry, you'll still need your protractor and you can simply measure off of the PowerPoint on the screen in front of you. So your do now task is there. So you're going to classify the type of angle shown in red and green in each question. Remember our types of angles, we've got acute, obtuse, reflex and a right angle. So you don't need to measure them, simply tell me which angle those are and answer those 5 questions for me. So if you pause the video while you do that, and then we'll put up some answers. Okay, so hopefully you've labelled these on and answers will be appearing now for angle. So remember, an acute angle is one that is less than 90 degrees. An obtuse angle is larger than 90 degrees but less than 180. And a reflex angle is greater than 180 degrees. Our right angle, as you can see on number 4 where it's wrong, is 90 degrees. That's not a 90 degree angle, so you wouldn't use that notation. And then on number 5, correct name of this angle. The angle formed, it's the letter in the middle that we're looking for, so it's X, Y, Z, or you go the other way and call it Z, Y, X. And the 2 line segments, X, Y, which could also be referred to as Y, X, and then Y, Z, or Z, Y for that one. So today, this is our hook about some cricket. So, in the sport of cricket, the bowler must bowl the ball with a straight arm as part of the laws of the game. It states that only a flexion, so that's the bending of the limb there, of 15 degrees in the elbow is allowed. Many players who have suspect actions are tested at Loughborough University to see if they need to be banned from bowling and their bowling technique requires adjustment. If you were to look at the bowling actions below, which bowlers should you think be banned? And how did you make your decision? So once again, we will have a little look later at this again, but see if you can decide now, based upon the law of 15 degrees of bending at the elbow, who would be allowed to bowl from that. Okay, so today we're going to know how to estimate the size of an angle from sight, understand how to measure angles up to 180 degrees. Okay, so we're only going to be looking at acute and obtuse angles today, no reflex angles, and be able to solve problems in real context with angles. So, estimate the size of this angle. Okay, so as these come up, I want you just to pause the video. You're not going to use a protractor. You're going to estimate what you think that angle should be. So each time they come up, pause the video and have a go. So this one, hopefully we should all know as an estimate that would be 90 degrees. Now, this next one, have a go at that. So we know where 90 degrees is, and if it was a completely straight line, we'd know it's 180. It looks somewhere in between those two, between 90 and 180. What's in the middle of that? 135 degrees would be a sensible estimate there. Next one, again, 90 degrees we know is a straight line up. It's halfway between 0 and 90, so we'd go 45. This one, if you can picture that perhaps with more of a horizontal base to it and turn the shape around a little bit, might make it a little bit easier. And again, I would say that is 45 degrees. And did give a little bit away on this one, a straight line there, 180 degrees. And in this one, so we know 90 degrees would be that straight line. It's slightly less than 90, not by much there. So I think this one is a sensible estimate around about sort of the 85. So you're going anything that's less than 90, but I think it's got to be more than 80. So between 80 and 90 perhaps for that one. Next one, again, it's gone past the 90, but it's not near the middle section of 135. So we'd be looking at a figure of about, that one is, well, exactly measured, sorry, that was 111. So hopefully your estimate you went for somewhere around that sort of figure, like a 115, 120. Okay, but 111 is the exact answer for that one. So I've measured these just so you can figure out how good your estimate is. Okay, and this one. So we're getting quite close to 180 degrees with a straight line there, but we're a little bit less, and that measures exactly at 167. So see how close your estimate was for that. And last but not least, we've got a very shallow angle. Okay, and that one is in fact only 10 degrees. Only 10 degrees on that one. Okay, and the size of this angle, why can't I estimate this angle? Hopefully you can remember the definition for the angle there. Angles are formed by two lines that meet. These two lines don't meet, so we've got nowhere that we can measure an angle from. Okay, what is the size of this angle? So it looks a little harder then to estimate when you haven't got the lines there with you. Okay, but you can still have a go estimating it, and that one is 60 degrees. So hopefully you've been okay with these estimates so far. And now we need to remember how exactly to measure these accurately, and that is when we're going to bring out our protractor. So we looked at this on the previous lessons before half term, but we'll just have a quick recap as it has been a good week or so since you've looked at any of this. So here we go, there's our baseline. And again, those who haven't got the worksheet or anything like that, you can simply put your protractor on the screen and it will measure exactly the same angles here. Got the angle we're trying to measure there, bring the protractor in. You put your crosshairs onto the angle like so, with the 0 on the baseline. Be careful, there are two sets of numbers. And we've got 0 is on the inside numbers there. So we're going to use those. Go around, what's that? It's resting on the 40, so that there is 40 degrees. Okay. So once again, let's do some teach, and when I've got those done, you're going to have a go at the do section for me and pause the video appropriately. Here's my protractor, got it nicely on the baseline, crosshairs right in the middle there. That crosses quite clearly, reading from the 0 on the baseline, go all the way around on the inside numbers to 130 degrees. Again, we do the estimates because we know that angle is larger than 90, and so we know it's the 130. You know it would not be correct to put the 50 there. I want you to have a go at the one on the right hand side. So as I say, use the worksheet if you've got it. If not, protractor, place it onto your screen now and you can still measure it there. Okay, and that one we should get is 110 degrees. Next up, put my protractor on, crosshairs nicely where they should be, where the two lines meet. Measure around and we get 150 degrees. We're using the outside line this time because the 0 lines up there with the baseline. You use the 0 at the bottom. We've got the outside line, 150 degrees. Same for yourselves, the one at the bottom there on the do this section. That one we should get 120 degrees. So let's just have a think about a quick few questions here. And like we said before half term, one of the most important things is to know which scale we should be using. Is it the inside numbers or is it the outside numbers? Okay, so you've got to make sure on that baseline where that 0 is. If it's the inside or the outside, that's the one we're using, whichever line has the 0 on it. So once again, put your protractor on, line the crosshairs up. Where the two lines meet is where you want to put the protractor. And we can see where's the 0 on the baseline. It's the outside numbers there, because the inside one says 180, so you don't want that one. We want the outside numbers where it says 0. Measure around to the line, and that has the line going through about 60 degrees. Sorry, let's just show those bits. So baseline of the protractor is over the baseline of the angle, exactly. The baseline is on the 0 of the outside numbers, so we'll use those. Measure that round, and we've got 60 degrees. So here's a few more for you. What I'd like you to do, again, they're on the worksheet, but just simply measure off screen. If not, standard examples to measure all of those angles there. I've written on the bottom A, B, C, but also I've highlighted them in red, the angles that we need. So pause the video there for you, please, and have a go at those 5 angles. Okay, so you may have just got 1 or 2 degrees out, depending, because obviously the line is a little bit thicker, so if you measured from the bottom of the line or slightly differently, but these, you should be getting around about 130 degrees, sort of plus a couple of degrees either side. So maybe between sort of 127 to 133, you should be getting that as an answer. 157, 96, 42, and the last one is 14 degrees. Okay, here's a few slightly more complicated looking ones. So once again, on the first three, I've drawn the little bit of red to highlight the exact angles that you're after, but I have given the notation as well. On the second one there, that shape, I haven't highlighted them, but if you can remember, so we've got the first bit, angle ABH, might help to mark it if you've got the worksheet. Again, just measure on screen if not, and then you've got 8 further angles to work out for me there. So pause the video and we'll see how we do on those 11 angles. Okay, answers are appearing now for you. 112, 55, and then 143. And then the angles for the rest of them, 98, 84, 67, 97, 122, 82, 78, and 58. So once again on those, especially on the right hand side there, you may get very slightly different on the angles there. Okay, so say for example for 98 you measured it as 96, that's absolutely fine. If you've got maybe 100, that would be fine. It's got to be around that region. If you put 82, then I know you've done something wrong because you've read it off the wrong baseline. You've used the wrong part of the protractor for that one. Okay. Alex and Dora measure the angle using a protractor. Who do we agree with? Alex says it's 40, Dora says it's 140. Okay, so pause there, have a think. Who do you agree with and why? Okay, so hopefully on this one we should all be agreeing with Dora. Okay, it's clearly way past 90 degrees as an angle, and when we've got our crosshairs lined up correctly, which they are, the baseline goes through the 0 on the outside numbers, so you would use those all the way around, and on the outside number that is 140 degrees. Okay, on this time we've got a quadrilateral here, a 4-sided shape. I'd like you to measure the size of each of the interior angles in the shape. Okay, and then when you've got all 4 angles, firstly, what do you think they should all add up to? And then I'd like you to add up all your angles. Do they add up to what you think? And if they don't, why do you think they don't? Okay, so here are my angles that I measured earlier on. I had to go at this: 60, 127, 118, and 55 degrees. So I say, if you add up all your angles together, what should they add up to? Okay, as we've got a 4-sided shape, a quadrilateral, the interior angles should add up to 360 degrees. And in which case mine does. Why may yours not add up to be this figure? It might be a case of just very slightly 1 or 2 angles are out. So say for example 127, if you mark that as 128, which would be perfectly reasonable as an answer and would be fine, because that's very close to what I've gone for as well, then that would add up to 361 degrees in total. It's just very slight errors in the measuring. Because of the thickness of the lines, we cannot get it exact. Okay, bit more purposeful practice here. This is the key thing with protractor. Practice does make perfect. So keep putting these protractors on and doing every single question. Once you've got the hang of it, they really don't take long, but we need to get used to it with the notation and reading off the correct, either the inside or the outside part of the protractor. So pause again, and then we've got a collection there. So just remember, this sum means adding together. The difference between means you'll be taking one away from the other. Okay, so there's a little bit of bonus maths in there for that. So this one, RTS. So we're looking at the bottom right-hand side there. We get is 41 degrees. QRS, 130 degrees, because that is the whole angle there at R. On the RTS, so we are cutting that off as it's part of the triangle. The QRS is part of the full quadrilateral there. The sum of angles SRT and QRT. Now, you could see the smart way here, or you may have measured both. Okay, but QRS is the sum of angles SRT and QRT. So you could just use a figure you've used from QRS and you would get 130. Or if you'd measured the two individually and added them together, you still would get 130 degrees. The difference between QST and SQT, well, QST was measured at 88 degrees and SQT was measured at 28 degrees, so the difference is 60 degrees. Okay, last bit, true or false. Here's your shape. If you pause it now and fill in every single answer for me, and then we'll go through them all as one go. Okay, so first of all, we're going to look at angle ABC, and we're going to suggest that it is close to 90. Yes, I think that's fair there. That is close to 90 degrees. Without measuring, I can see triangle CBD has all of the same angles. Okay, so to be all the same angles, we'll be thinking that would be an equilateral triangle, and there are 180 degrees in a triangle, so each angle would be 60 degrees. That is false there. They don't all look the same angle whatsoever there. That's not then an equilateral or 60 degrees. CBA measured is 49. True. Again, should have said sorry a minute ago for this. If you measured it perhaps as 48, I'd suggest then you would be putting that as true. Okay, because that's very close to what it should be there. That's just your error rounding for reading off the thicker lines. EDC, 56, true. BCD, 45, true. CDB, 156. Now that one is going to be wrong. They've read it off the wrong number there. That I thought would most likely be the other way round. And so you'd be looking at around about 24 degrees. They've read off the wrong number there. Instead of reading off the inside number, the outside number, they've read off the inside number to get the 156. So you should read off the outside one for 24. CED is the same size as CDE. That is false if you measure those two. When measuring angles using my protractor, I can use either answer provided on the outside. Absolutely false. Don't ever do that. That's the whole point of this lesson. And the ones who looked at the protractor is make sure you know if you're using the inside or the outside numbers there. Now, there's a few little bonus questions on here for those that really want to be pushed. So have a look at these to see if you think these are correct. Pause the videos appropriately. There's a little bit more of some real-world examples with navigations and boat systems. And then there's the last little bit on exam questions, the hook, and I've given you a bit of help with that to see who should be banned. But today we've covered how to estimate the size of an angle, how to measure angles, and then there's a few extra real-world examples for you to investigate at the end there. So we'll have a few more lessons on angles coming up for you this week. So until then, look after yourselves and speak to you again soon in Year 7s.